Hello everybody, welcome back to a small commentary channel where we're looking at today prions. So this is part 2. In part 1 we looked at the different diseases, prion diseases in animals and in humans, and it is always fatal. Now we're going to have a look how prions, which are a protein in the brain, become rogue. So prions become rogue through a process of protein misfolding. Here's a simplified explanation of how this happens. Number 1, normal protein structure. Proteins in the body have a specific three-dimensional structure that allow them to perform their functions. These structures are determined by the sequence of amino acids in the protein and how these amino acids interact with each other. Number 2, misfolding. Sometimes, due to genetic mutations or spontaneous changes, a protein can fold incorrectly. In the case of prions, the normal prion protein changes its shape to an abnormal form. Now, I would have to show you the normal form is expressed by a capital P, a little r, a capital P, and then a symbol like what I pointed, I think it just two sides of a triangle and a capital C. And the abnormal form is a capital P, a little r to a capital P to that two-side triangle without a bottom, and then a capital S with a C. Doesn't mean much to me, not being a scientist, but it may mean something to you out there who are a little bit more knowledgeable than me. So number 3, template-induced misfolding. The abnormal prion protein has a unique ability to induce the normal prion protein to also misfold and become abnormal. This process is akin to a chain reaction where one misfolded protein can cause other normal proteins to misfold. Number 4, aggregation. These misfolded proteins tend to clump together, forming aggregates. These aggregates are resistant to the usual ways the body breaks down and recycles proteins, leading to their accumulation. Number 5, cell damage. As these misfolded proteins accumulate, they disrupt normal cell functions, especially in the brain. They can cause cell death, leading to the characteristic spongy degeneration seen in prion diseases, where brain tissue develops holes and takes on a sponge-like appearance. How sad. Number 6, spread. The misfolded proteins can spread within the brain and to other parts of the nervous system, causing the progressive symptoms seen in prion diseases. The exact reasons why the normal prion protein misfolds are not fully understood. It can happen due to genetic mutations. Certain genetic mutations can make the prion protein more prone to misfolding. Spontaneous misfolding. Sometimes the prion protein can spontaneously misfold without any genetic mutation. Infectious prions. Exposure to misfolded prion proteins from contaminated food, medical instruments, or other sources can introduce rogue prions into the body, starting the chain reaction of misfolding. Because prions are just misfolded proteins without genetic material, they are extremely resistant to standard methods of sterilization and disinfection, making them particularly challenging to control. How awful. At uni, I studied the family of filial viruses, which includes Ebola. I did another one. There are only 4 viruses. I did the Marburg virus, and I thought they were bad, but to get a prion disease, my sympathy, I don't know how common it is. I just wanted to explore this topic a little bit more after watching David Paulides. So this is the end of part 2. As always, thank you very much for watching. You cherish every moment. Love the best you can, and every life matters. Love, light, and blessings. Have a good Monday and a great week. Bye from Jem.